So in this warm up here, we're just going to kind of review this dilation, how to work with it when you're given a scale factor, and how to find the scale factor. So in the first one, we have a scale factor of 4. So everything's going to multiply by 4, both your x and your y coordinates. Because I don't have a lot of room, I would prefer you didn't do this in your head, but I'm going to do it in my head this time. So 1, 2 is going to become 4, 8. Negative 6, 0 is going to become negative 24, 0. And 3, 1 is going to become 12, 4. In 2, to find your scale factor, if you remember, it's dilation over original. They're giving you two measurements. They're giving you 3 by 5 and 7.5 by 12.5. You only have to pick one measurement that matches up. So you could use the 3 and the 7.5, or you could use the 5 and the 12.5. It doesn't matter. I'm going to use this 3 and the 7.5, so that's 7.5 over 3. That would reduce to actually 2.5. So we grew the picture 2.5 times its original size. Today we're looking at what is known as composition of functions, and composition means many things put together. So basically, if you're given shapes, can you determine what sort of transformations were used to go from the original to the new image? So just kind of reviewing that with translation, everything's going to stay the same length. The direction's going to stay the same. All we're doing with translations is we're sliding. With reflections, our length is still going to stay the same. When it talks about orientation, that's pretty much your direction. And that should make sense. We're getting a mirror image. And reflection means flip. And then we have rotation, and again, our length is staying the same, but it's our orientation or direction that's changing. And rotation means to spin. Before we get started too far, we also want to talk about congruence and similarity. And congruence means that they're the same size and the same shape. And basically our three main transformations are going to keep that congruence between shapes. Our new image and the original are going to be the same size and shape. Similarity is when they have the same shape but not the same size. And the only transformation that messes with that is dilation, because we're shrinking or enlarging. We're changing the size of that new shape. But if it starts as a triangle, it's still going to end up as a triangle. So looking here, I'm going to zoom out a little bit. It doesn't look like my whole shape transferred over. Alright, so there's my original. And my new shape, I'm trying to remember how it was drawn. I think it was something like this. So we're going to use these two shapes. And basically, how do we get from one to the other? Everybody's going to have different answers of how they're going to take your original shape and get it to match up on top of the new image. And as long as you can justify your answer, as long as you can explain why you chose what you did, it doesn't matter what order you do them in. For me, I'm going to translate. So I'm going to translate it over, and then I'm going to reflect it over the x-axis. So that's going to reflect it down. Some of you may translate and then reflect. Some of you may rotate. Again, it doesn't matter. Yours don't have to match mine. But you're going to be asked to justify and explain why you think these work. So here I actually have the two figures that look similar. And we're going to try to figure out how to go from the original over here to this new one. And for me, what I'm seeing is I'm looking at it And I'm seeing a rotation and then a reflection. Because if I rotate it 270 degrees, it would look something like this. And then I can reflect it over the y. So I'm going to say a rotation and then a reflection. So here we're looking at taking the blue triangle onto the yellow one. So in order to map the two for me, I would do a reflection and then a translation. Some of you may rotate, and again, I can justify a reflection and a translation because when I reflect it, it's going to look something like that, and then I can translate it down. Now with this one, you actually want to start and you want to look at it, and you'll notice that this is false. This is not possible. And the reason it's not possible is these two images are not congruent. This blue one has a box 1 spot up from that bottom foot. The yellow one has the box 2 spots up from its bottom foot. So it's not actually possible to transform this one without manipulating the actual figure itself. So with this one, hopefully you notice that there's a dilation. We went from the blue one to the yellow one, so we made it skinnier. And for me, this is going to be a rotation. I'm going to rotate it up. I'm going to translate it, slide it down into place. Then it's also going to have a dilation on it. Try these two on your own. For the first one, I would reflect and then translate. Second one, not possible again, if you look at that extra piece. These are not congruent, so there's no way that we could be able to get them to match. So now we're going to look at identifying the new points. So now we're going to rotate 90 degrees counterclockwise, which means 270. If you remember, 270 was negative yx. Once we do that, then we're going to translate the point. So A started out at the point 1, 2. I'm going to rotate it. When I rotate it, that's going to make it negative 2, 1. Now I'm going to translate it, and it's going to be my new x value, so negative 2 plus 4 and 1 minus 1. So my final point is going to be 2, 0. B prime is going to be at negative 4, 6. We are going to rotate it. That's going to make it negative 6, negative 4. We're then going to translate it up 4, so plus 4, and we're going to translate it down 1. And that's going to take it to negative 2, negative 5. C prime is going to go from negative 5, 0, and it's going to go to 0, negative 5. Translate it, so 0 plus 4 and negative 5 minus 1. And that's going to take us to 4, negative 6. Same thing here. This time we're reflecting it and then rotating it 180 degrees. You're going to want to take the points off the graph. So A is going to be at negative 3, 5. Negative 3, positive 5. B is at negative 4, 4. C is at negative 3, 3. D is at negative 1, 2. And E is at negative 1, 4. Reflected across the y-axis. If you remember, when we reflected across the y-axis, the opposite coordinate's going to change signs. So it's my x-coordinate that's going to change. So in the first piece, A is going to switch to 3, 5. B is going to switch to 4, 4. C will switch to 3, 3. D will switch to 1, 2. And E will switch to 1, 4. Rotating at 180 degrees, that changes my signs again, but this time negative x and negative y. So that's going to make A prime negative 3, negative 5 for my final answer. B prime will be negative 4, negative 4. C prime will be 3, will be negative 3, negative 3. D will be negative 1, 2, negative 2. And E will be negative 1, negative 4. So basically we reflected it over into the first quadrant, and then we rotated it down here into quadrant 3. Here we're going to translate, and then we're going to dilate. So A is at negative 3, 0. When we translate that, that's going to become 2, negative 3. We're going to dilate it by a scale factor of 1/2, so multiply everything by 1/2. And that's going to give me 1 comma, negative 1.5. B is at 2, 4. I'm going to translate it. When I translate it, it's going to become 7, comma 1. I'm going to dilate it by 1/2, and that's going to become 3.5, comma 1/2, or 0.5. C, 3, 1 is going to translate and become 8, negative 2. Dilate it by 1/2, and I get 4, negative 1. D is negative 4, negative 3. It's going to translate, and I'm going to get 1, comma 0. Dilate it by 1/2, and I'm going to get 0.5, comma 0. Try these two on your own. So in the first one, we're reflecting across the x-axis in a 270-degree rotation. Remember that the 270-degree rotation, that's where we had negative yx. So when we reflect the first point, it's going to become 1, 1. This is going to become negative 2, positive 1. And this will become negative 2, negative 3. Then when I reflect this first one, this is going to become negative 1, 1. Second one is going to become negative 1, negative 2. And the third one is going to become 3, negative 2. This bottom one down here, we're starting at the point, we have 2, 1. We have 4, 1. We have 1, 4. And what's the last one? 5, 4. We're translating it and then dilating it by a scale factor of 3. When I translate it, for the first point, I'm going to get negative 2, 2. Second one is going to become 0, 2, 0, 3. Boys. The third point down here is going to become negative 3, 6. And the last point is 1, 1. Now I need to dilate everything by a scale factor of 3. So that first point is going to become negative 6, 6. The second point right here is going to become 0, 9. Bottom point is going to become negative 9 and 18. And this last point over here is going to become 3, 3. Homework's going to be in your textbook, page 507, problems 1 through 9. If you don't have your textbook at home, if you go to Connected, so it's www.connected.mcgraw-hill.com, you should be able to get into your textbook that way.